Welcome, dear student. How are you? I hope you are all well. तो आज जिस टॉपिक में हम बात करेंगे वो है थर्मोडायनामिक प्रोसेस. तो व्हाट इज थर्मोडायनामिक प्रोसेस एंड व्हाट इज द work done and its features. In many channels or many institutions you learn about it, but today we shall learn it very easily. If you have any confusion about this topic, please see my channel. I will explain it very easily. So don't waste time, start it. Thermodynamic process. First we see the definition of thermodynamic process. Write with me in your exercise copy. A thermodynamic process is a process in which thermodynamic variables undergo changes with time. A thermodynamic process is a process in which thermodynamic variables means pressure, temperature, volume, density, etc. Thermodynamic variables undergo changes with time. Due to elaboration of time or passing with time, the value of the variables is changes. So this is the definition of thermodynamic process. Write in your copy. Now there are 4 thermodynamic processes. So we can write it in a thermodynamic process in a chart. Thermodynamic process and special features. Number 1 is isothermal process. Special features is temperature constant. CONST means constant. Number 2, isobaric process. Pressure constant. Number 3, isochoric process. Volume constant. And number 4 is adiabatic process. Here no exchange of heat that is delta Q is equal to 0. No exchange of heat between system and surroundings. These 4 is the basic thermodynamic process: isothermal, isobaric, isochoric and adiabatic. So let us start with the isothermal process. So at first we write the definition of isothermal process. What is the definition? An isothermal process is a process or thermodynamic process in which pressure and volume are may be changed, but the temperature remains constant throughout the process. Whole process. This is the definition of isothermal process. An isothermal process is a process in which pressure and volume are may be changed, but the temperature remains constant throughout the whole process. मैं इस चैनल में जो डेफिनेशन लिखा रहा हूँ तो उसको आप डायरेक्ट एग्जाम में भी लिख सकते हैं. So in my channel I can understand you the main concept as well as I can read I will write the all the answer which can you directly write in your exam. So let us इसको लिख लो. Let us understand it with an example. Suppose there is a gas container in which gas is enclosed. Now, if a piston which is frictionless and movable piston, this piston must be frictionless and movable. Piston is allowed to compress the gas. Now, when the gas is compressed, work is done on the gas during compression. इस बात को हमेशा याद रखना. In time of compression, work is done on the gas. So the temperature increased, but we know that isothermal process temperature remains constant. So this increased temperature can be transferred to the surroundings so that the temperature of the system remains constant. So for transfer the temperature surroundings, the wall of the container must be very well conducting. Again, when the friction is the gas is allowed to expand, the reverse phenomena is occurred. When the gas is allowed to expand, then work is done by the gas during expansion, the reverse phenomena. So here temperature not increased but decreased. So as temperature decrease, so some heat must be conducting from surroundings to the container of the gas, so that the temperature remains constant. So during the whole process, the temperature remains constant by conducting heat from the surroundings or to the surroundings. Now, what is the condition? Very, very important. What is the condition of isothermal process? Number 1, the wall of the container must be well conducting, so that heat can easily transfer between the surroundings and the system. And number 2 is it must be a slow process, because it is necessary to be the sufficient time to transfer heat from the gas to the surroundings or from surroundings to container of the gas, so that the temperature remains constant. So, this cannot be done very quickly. So, it must be a slow process to maintain the constant value of the temperature. This too is the main condition of isothermal process. Now, what is the relation between thermodynamic variables, that is pressure and volume, in isothermal process? So, again we can now go with the relation. We know that ideal gas equation is PV is equal to nRT. Now, for a fixed mass of gas, N equal to constant, R equal to constant, as it is universal constant, it is known as universal gas constant. And for isothermal process, T is again constant. So, we can get PV equal to constant is the basic relation between temperature and volume. If we draw a graph taking volume and x-axis and pressure along y-axis, we can get a hyperbola rectangular curve, and we know, again you can see my previous video, that is the work done is done by, if we take the area of this curve, that is the area enclosed by the isothermal curve, and the volume axis is the total work done, gives total work done in isothermal process. Now we can calculate the work done. I hope तुम लोग को अच्छा लगा होगा, और I can try in this manner that after understand this, you can directly note down in your exercise in your exam copy. So please watch my channel for further interesting video. I can complete all the syllabus of 11 and 12 as well as. Now, work done in isothermal process. This is very important for class 11 student. Suppose a gas is again enclosed in a container, and the piston is moved from position A to position B due to expansion of gas. If we get heated from it outside, then it moves from A to B with further a distance dx, and A is the from A to B, and suppose alpha is the cross sectional area of piston. So, for moving through a further distance dx, the work done is dw equal to, we can know that P dV. From first law of thermodynamics, we can know that dq equal to change in internal energy plus work done. but as we know that internal energy is directly depends on temperature for ideal gas. So as temperature become fixed, so dV is also fixed, therefore this term is 0. So here dq is equal to direct P dV. That is the heat is change, therefore the heat supplied by the gas to the gas, the heat supplied to the gas is equivalent to the work done by the gas an amount P dV. So as dV equal to 0, we can directly get dW equal to P dV. Now if volume changes from V1 to V2, then total work done during an isothermal process, we can going to calculate W integration dW equal to integration of P dV from volume P1 to V2. Suppose this the coordinate of point P1 P2 V2, coordinate of point A is P1 V1 and B is P2 V2. Now from ideal gas we can note PV equal to RT or nRT. If we take n mole of gas, then what is the value of P? nRT by V. Put the value of P, integration V1 to V2 nRT by V dV. As this term is constant, put it outside the integration. nRT 1 by V dV, इंटीग्रेशन लिमिट इज V1 to V2. अगर आप इंटीग्रेशन नहीं समझ सकते तो ये जो हमने यहाँ पे जो फॉर्मूला यूज़ किया है वो है इंटीग्रेशन dx बाई डी एक्स इक्वल टू ln x और log x. सो nRT दिस इज ln V1 to V2, दैट इज V का जाएगा में in place of V we can use V2 minus V1, that is nRT ln V2 minus ln V1. Now ln A minus ln B is equal to ln A by B. So the final expression is if we write it in this side nRT ln V2 by V1. This is the total work done during an आइसोथर्मल प्रोसेस. अगर हम इसको लॉग में ट्रांसफर करें, ln और लॉग एक ही चीज़ नहीं है, अगर आप इसको लॉग में ट्रांसफर करते हैं तो इसके साथ एक फैक्टर हमको मल्टीप्लाई करना पड़ेगा जिसका वैल्यू है 2.3026 nRT log of V2 by V1. But we can find the value directly from the calculator as ln function is available there. So this is the total work done in isothermal process. So in this video you can get all the phenomena of isothermal process, thermodynamic process, what are the different thermodynamic process and detailed discussion on isothermal work done isothermal process. Next day we will discuss with adiabatic process. If you like my video and know the better और न्यू थिंग्स अगर जानना चाहते हैं तो मेरा वीडियो देखते रहिए. अगर अच्छा लगे तो प्लीज़ सब्सक्राइब कीजिए. थैंक यू.